Back in problem 3-15C, one of the examples was x minus 3 times x plus 3, and when you multiply these out, you would get x squared minus 9. You didn't have to do this one, but I want to show you this example. So if you look here, we notice something special. There is only a binomial here, and it is just our first term and our last term squared. Well, how does this happen? Let's look. So we get x squared minus 3x plus 3x minus 9 when we fill in the box. So because we have a minus 3x and a positive 3x, those cancel each other out, and I'm left with a binomial. This would be the same case if we had, say, x squared minus 16. We could rewrite that as x minus 4 times x plus 4 as our equivalent statements. These are special because they are called the differences of squares. You're going to want to write this in your notebook. Important, okay? Differences of squares are easy to factor because when we are working with them, if we have the differences of squares, we can quickly write their two binomials. So key things, there must be subtraction. Must be subtraction, hence why it's called differences. And both terms must be able to square. Square root. Must be able to square root. So if we look at a couple more examples here, if I had w squared minus 81, I have my minus sign. 81 is a perfect square, so I know that's going to be a 9 and a 9. Got to have my plus and minus. And w squared is also a perfect square. It's w times w. And that's my solution right there. Another example might be negative 16y squared plus x squared. Now you look at this and say, hey, I don't have a subtraction sign, it's a plus. But I could flip these because of the commutative property, and it becomes x squared minus 16y squared. So again, x squared is a perfect square. I've got my subtraction. 16 is a perfect square, and so is y squared. So I can write this out. I know I'm going to have my x and x. I got to have a plus and a minus so that they cancel out in the middle. Square root of 16 is 4. Square root of y squared is y. And there's my answer. Okay? So again, this is called the difference of squares. And in the next problem, you're going to decide which of the 4 that you could apply this rule to, and then you will go ahead and do that on your own.